This video is going to cover section 6.2 for statistics. We're going to look at the binomial probability distribution. So, what is a binomial probability distribution? Well, it's a discrete probability distribution. So just like we talked about before, distribution, except there's only two possible outcomes. So the criteria for a binomial experiment is you have a fixed number of trials. How many times am I going to flip the coin? How many times am I going to do this? Each trial is independent, meaning that the probability is the same for each trial. And then finally, what makes it binomial is that there's only two outcomes possible. Excuse me. Now, we often refer to those as success and failure. And success just means you got the outcome you're looking for, not necessarily a positive thing. Like heads and tails, if I'm counting heads, heads would be the success. Notation that you're going to see, N is the number of trials, how many times you do it. P is your probability of success, probability of getting what you're looking for, which means 1 minus P is the probability of failure or of getting the other option. And then the X is going to be the number of successes that we're looking for. So let's decide if these are binomial experiments. A basketball player, or an experiment in which a basketball player who historically makes 80% of his free throws is asked to shoot 3 free throws, and the number of free throws made is recorded. So do we have a set number of trials? Yes, we're doing 3 free throws. Are they independent? Yep, each shot has nothing to do with the next shot. Do they all have the same probability? Yes, it's 80%. And are there only 2 outcomes? And it's either, yes, he made it, or no, he didn't. So yes, 2 outcomes. So it is a binomial probability. Now let's look at the next one. According to a recent Harris poll, 28% of Americans state that chocolate is their favorite flavor of ice cream. Suppose a simple random sample of size 10 is obtained, and the number of Americans who chose chocolate is recorded. So do we have a set number? Yes. Are they independent? Yes, because all the people are different. Is the probability consistent? Yes, it's at 28%. Now the trick comes in with this one. How did they ask? If they said, is chocolate your favorite, and the only choices you had were yes or no, then yes, it's a binomial. If they said, what's your favorite flavor, and you could have answered any flavor, then no, it's not. So that would depend on the question. All right. And then the last one, a probability experiment in which 3 cards are drawn from a deck without replacement and the number of aces is recorded. So if we're only recording aces versus non-aces, that would meet the 2 outcomes. But without replacement means now we're going to dependent. The probability is going to change each time you take a card out. So this one is not a binomial. And just a reminder, success is just what we're looking for. It's not necessarily positive or negative. All right, so how do we find these probabilities? Well, according to the American Red Cross, 7% of people in the United States have a blood type of O negative. So we know right now our probability is 0.07. A simple random sample of size 4 is obtained, so N equals 4, and the number of people X, blood type O negative, is recorded. Construct a probability distribution for the random variable X. So we have a couple options for how to do this. We can say, all right, the first person is either success or failure, meaning O negative or not. And then the second person is success or failure. And then the third person is success or failure. And then the fourth person is success or failure. So then we could write out all our possibilities. So the first one would be 4 successes. So that's 4 good. And then we have 3 successes and a failure. And then we have success, success, failure, success. That's 3. Success, success, failure, failure. So that's 2 S's. Then we have success, failure, success, success. That's 3. Success, failure, success, failure. That's 2. And we can do this all the way down and find out how many 4s, 3s, 2s, and 1s there are. Or the last one, 4 failures, would be 0 successes. And then we find the probability for each of those. So if I were doing this one, my probability of success is 0.07. So my probability of failure is 1 minus 0.07. And then probability of success. Multiply these all together, and we get 0.00032 of a probability just for that one right there, and there's 3 of those. So we have to figure out all of the 3s and add them together, all of the 2s and add them together. So the more pieces you have, the more complicated that gets, but you can do it that way. Even better, our calculator will do the math for you. There's an option, binomial probability distribution function, or binom PDF, where you tell the calculator the number of trials, the probability of each trial, and the number of successes, and it'll give you the probability. It'll do all this math where it finds all of these possibilities, finds the probability of each one, and then adds all the ones that go together. On your calculator, to get to that, you hit second vars and then scroll down until you see A. So let's do that here. So second is the blue button. Vars is down here next to clear. And then you're going to scroll down until you get to A, binom PDF. The P is important. Then your calculator will either look like mine, where it just has a parentheses and you type those numbers with commas, or it'll ask you specifically trials. That's where you put N, probability, and then X value. So for this, we did 4 trials, and then our probability was 0.07. And for the table here, we want 0. And we get 0.7481. Then we do it again. Second vars, go down to A, 4 trials, 0.07. This time we want X is 1, 0.2252. So you keep going with this. You do the other ones and then see how you did. So 4.072. 0, 2, 3, 1, 3, and then 4. So here we get 2.401 e to the negative 5. That's the same as scientific notation. It's saying 2.401 times 10 to the negative 5th, which moves our decimal place 5 times this way. So 0.00024. If the number's any higher than 5 here, negative 5, it's just going to be 0, because if we were to round it to 4 places, it would still be 0. So that is okay to round at that point. So that's how you do that. The way you're going to show your work on your paper to get credit is to essentially write this with the numbers that you typed in. That way, if you just typed P wrong, I can give you partial credit because I can see that you did the rest right. So just writing this, like for number 2, we'd write binom PDF. That tells me you're using the P. And then you'd put 4.072. I would count that as showing your work. Now, that's a lot if we're talking about exact, you have to do it for each trial. So if we were picking 100 people, we'd have to do it for 0, 1, 2, all the way up to 100. Sometimes we want to know like less than 3. Well, less than 3, we'd add all these up. There's also a way to do that on the calculator. So first, let's review our symbols. At least, no less than, greater than or equal to looks like this. More than or greater than looks like this, so no line. And then we have our fewer than or less than or equal to, and exactly equals or is. So those symbols are going to help us. Now we have some new notation here. Mean sub x. Whenever you see just the x there, that's saying ding, 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 binomial probability. And here's how you find it. N times p. And then you'll have standard deviation sub x, which is also binomial, and you find it using this, square root of np1 minus p. Sometimes you're just asked to describe a distribution, and that's how you describe it, with the mean and the standard deviation. So as we keep going, we're going to see different sub-letters down there, but when it's just a plain x, it's binomial distribution. All right, so what else can our calculator do? Well, we talked about how PDF is exact when it equals. So when x equals a number, we do binom PDF. Now, if we want a range, like less than or equal to, greater than or equal to, any of those others, we're going to use CDF. And they're both in the same place, so second vars. And then PDF is A, CDF is B. And again, the calculator is going to ask you for trials. Oops, that's not a highlighter. Trials, probability, and then the x value, the number you're looking for. And if it doesn't ask, then you're going to type it just like that with commas. What you want to pay attention to is based on what it's asking, you're going to type a different number at the end here. So if it's less than or equal to, you just use the number. If there's no equal to, you subtract 1. Remember, these are all discrete. So if it's less than 3, the next highest number it can be is 2, which is why you're doing this. Greater than, you're going to do 1 minus before you type it. And if you're in between 2, you're just going to do both of them subtracted. So it's a lot of details, a lot of little things, but you're going to have this all on your note sheet to help you and to refer back to. So let's look at one. According to the Gallup organization, 65% of adult Americans are in favor of the death penalty for individuals convicted of murder. So that's our P. In a random sample of 15 adult Americans, what is the probability that exactly 10 favor the death penalty? So we're saying our outcome, our success is that they favor the death penalty. Our failure is that they don't. So exact tells us we're going to use this one. So what I would write is binom PDF. My N is 15. My P is 0.65. And A is 10. That's what they're asking us. And then I would type that right in the calculator. So second vars, go down to A, 15, comma, 0.65, comma, 10. And I get 0.2123. So 21.23% chance that exactly 10 would favor the death penalty. No more than 6. So that's the same as less than or equal to. So we're going to do this one. Actually, I'll bring it over here. Less than or equal to. So this time we're going to write binom CDF. N is 15, P is 65, and this time we're saying A is 6. So second vars. Now we're going to choose B, 15, comma, 0.65, comma, 6, and we get 0.0422. So it's 4.22% that no more than 6, so 6 or less, would favor the death penalty. So that's that kind of example. This, A through F, goes through all of the possibilities. So watch the ones that you need. Feel free to go back up here and check it. Pause the video and try it once you feel ready to try it. So mean and standard deviation. This was mean sub X, which is NP. According to CETA, 41% of U.S. households are wireless only and a simple random sample of 300. So we're saying N is 300 and P is 0.41. All right, so 300 times 0.41 is 123. So the mean of these, if we asked all of these houses, we would expect an average of 123 if I did this a whole bunch of times. Now, the standard deviation was the square root of NP1 minus P. So N is 300, P is 0.41, 1 minus P is 1 minus 0.41. Type that in the calculator. Second square root, 300, 0.41, 1 minus 0.41. And we get 8.5188. So that would be the standard deviation we would use. Now let's do these. So exactly is equals. So that's going to take our PDF here. And then less than 130. So that's going to be this less than 1. Oop, things are moving. Why are they moving? What's happening? This is at least, so greater than or equal to 120. Why is it not staying? All right, well, let me try something different. I'm just going to slide these so they're all on the same screen. All right, so this one goes here. This one goes here. Greater than or equal to goes there. Then we're doing between, so it's 115 less than or equal to X, less than or equal to 150, so that's going to be this one. And then would it be unusual for 243 households? We're going to do the exact again and then see if that percent is unusual. So now we would decide. So this is telling us PDF. And we would do N, which is 300, P, which is 0.41, A is 105. Less than was this one, so CDF, N is 300, P is 0.41. Then it says A minus 1, so 130 minus 1 is 129. Now we're going to do greater than or equal to, so 1 minus binomial CDF, 300.41, and then it says A minus 1, so 119. And then E is binomial CDF, N is 300, P is 0.41, B is 150, that's the bigger number. And then minus binomial CDF, N is 300, P is 0.41, and then it says A minus 1, so it'd be 114. And then we're back to the exact for F, so binomial PDF, 300.41, 243. So now we would type those in our calculator. So if I do that, come on. Here we go. Second vars. Binomial PDF, 300.41, 105. We get 0.0050. Then we do CDF, 300.41, 129, 0.7777. And now we literally just type 1 minus, just like that. Binomial CDF, 300.41, 119. 6583. And then binom CDF, 300.41, 150, close the parentheses, minus, and then do it again with the new numbers. Nope, that's not what I wanted. Delete. 300.41, 114. And that is 8401. So those gives us all those probabilities. And then the last one, if we're trying to do it's unusual, remember 5% is our guideline if we're not told differently. So we go back to our PDF. We do 300.41, 243, and we get something to the negative 46. So that means we have pretty much a 0% chance of getting it because we'd have 46 zeros in front of that 9, or 45, yeah. So yes, 0 is less than 5%, so that would be unusual. So that's how you do binomial probabilities. Let me know if you have any questions.